So now come to the point, current electricity. Current electricity. So what do you mean by current and electricity? Current and electricity क्या है? No, current electricity, the physics of the charge at rest is called electrostatic or static electricity. So the physics of charge or at rest, charge at rest is called current electricity. Current electricity. Okay, physics charge is called current electricity. So the study of the electric charge in and motion is called current electricity. So for what do you mean by electronic current? If two bodies charges with different potential, let's say this is one bodies and this is also one bodies, it is also current by positive charges and it is also by negative charges. If two bodies charged by different potentials are connected together means of conducting where and the charge begin to follow from one body to another body, the charges continue to follow till the potential of the of two bodies become equal. इसका मतलब ये है कि अगर ये बॉडी का जितने सारे पोटेंशियल चार्ज है, इसका जो पोटेंशियल चार्ज है ये तब तक फॉलो होता रहेगा जैसे कि इस पॉजिटिव चार्ज ये नेगेटिव चार्ज, तो ये एक दूसरे से इतना फॉलो होता रहेगा जब तक ना इन दोनों क्या करती है कि इक्वल बन जाती है। ठीक है, तो इसी को अगर डेफिनेशन के अंदर लिखूं तो क्या डेफिनेशन होगा? डेफिनेशन, तो डेफिनेशन इसका ऐसा है कि द फॉलो ऑफ इलेक्ट्रॉनिक चार्ज थ्रू ए कंडक्टर constitutes of an electronic current. The follow of electric charge, follow of electric charge through a conductor, through a conductor, through a conductor constitutes or an electronic current, constitutes an electronic current, constitutes an electronic current. Okay, so the follow of electronic charge through a conductor, follow of electronic charge through a conductor constitutes an electric current. Remember that. Okay, wait a single minute. Now if the charge del q passes through an area in time t, let's say this is a time area, ठीक है, और del q यानी delta amount of q passes through an area of electronic charge are passing, delta amount of del q amount of electronic charge here, q represent the adhan yani passes through an area t to t plus del t, then the current I at a time is given by, agar if given that this is a field and q परिमाण charges are passing through this with a del t time, okay, so I is equal to definitely q by t, yani how much charges are passing through an area per unit time is called basically current. The definition of the current is basically electric charge divided by time. So what it will be? Electric charge divided by time. Understand? Let's move on next topic. Then mathematically how you will represent? Mathematically it will represent that current I is equal to limit del t tends to 0. Okay, so del t tends to 0, del q divided by del t is equal to del q by dt. So the rate of change of মানে charge per unit area per unit time is called also unit charge. Okay, so q is the charge that follows across the given area. মানে q is the charge that follows the across the given area. Now come to the point how you will define any charge. So here you can get lighting फ्रॉम स्काई आप देख सकते हो कि आसमान में बहुत सारी बिजली कड़कती है, ठीक है, कुछ इस तरीके का बिजली कड़कती है। तो इसके अंदर क्या दिखाई देती है, माने इट्स आर कमिंग बिटवीन माने व्हेन माने दिस टाइप ऑफ चार्ज, ओके, बिटवीन टू क्लाउड्स और फ्रॉम फ्रॉम ए क्लाउड्स टू अर्थ, माने इसको दिखाया जाता है कि इट्स कमिंग फ्रॉम वन क्लाउड, ओके, to another cloud, and it's happened because of the মানে friction between two clouds, between two clouds. It's this kind of things happened because of the friction between two clouds. So when two clouds are frictioning both of the time, then definitely this type of electricity will come out. Okay, and this type of electricity comes because of the that reason. Okay, so and this type of current is transistent current. This type of current is called transistent current. Okay, so what is the transistent current? So transistent current means it is a which মানে that type of current it's মানে exist short time period. It happened in the short time period. So that's the main reason. That's the main reason it is calling a transistent current. I hope you understand that. Let's move on. The unit of SI unit of current is what? So for SI unit of current is what? Ampere. Ampere. AMP. Okay, so what is the definition of ampere? If 1 coulomb of a charge across an area in 1 second, if 1 coulomb charge of if 1 coulomb charge of if 1 coulomb of charge cross an area in a second, then it is called an 1 ampere. Definition: if 1 coulomb if 1 coulomb of charge passes through an area, okay, 1 coulomb of charge passes through an area in 1 second, okay, in 1 second, then the current through that area is 1 ampere. Then the current through that area in one second, that the current through in the area time taken 1 second, and it is called as what? It is called as 1 ampere. It's called as 1 ampere. Okay, so 1 ampere, basically 1 ampere is equal to 1 মানে 1 coulomb divided by 1 second. 1 coulomb divided by 1 second. 1 coulomb divided by 1 second is called what? Is called 1 ampere. It is clear that 1 ampere. So what it will be? इसका यूनिट क्या होगा? ठीक है, इसका यूनिट बेसिकली 1 ampere is equal to coulombs per second inverse. Coulombs per second. So it will be written as 1 coulomb per second inverse. Okay, so CS inverse. So ampere is one basic unit for SI unit. We shall formally define in chapter 4 in terms of the magnetic effect of current. Smaller currents are expressed in the following. जैसे कि you'll get that 1 microampere is equal to 10 to the power minus 6 ampere. 1 milliampere is equal to 10 to the power minus 3 ampere. So current in the domestic balance, there is the different kind of balance, a place where current is defined. Okay, now distinguish between conventional and electronic current. Now we will distinguish between conventional current and electronic current. Conventional current and electronic current and electronic current মানে difference. Okay, so for difference between conventional current and electronic current. So by the conventional current, the direction of the motion is positive charge is taken the direction of the electric current. माने जिसकी तरफ से पॉजिटिव चार्ज की डायरेक्शन होगा, ओके, कन्वेंशनल करंट की जो डायरेक्शन है उसी डायरेक्शन की तरफ होगा. माने पॉजिटिव डायरेक्शन, अगर पॉजिटिव डायरेक्शन कन्वेंशनल करेक्शन माने कन्वेंशनल बाय कन्वेंशन द डायरेक्शन ऑफ मोशन ऑफ पॉजिटिव चार्ज इज टेकन द डायरेक्शन ऑफ द इलेक्ट्रिक करंट. Let's say this is conventional current. So these are the conventional current. Okay, so the direction and the direction conventional current direction is this side. Okay, as the cell type electric current, so it is the negative charge particle, so it is also that side. মানে electrons are the direction. Okay, so the direction of motion positive charge is taken the direction of the electric current. The direction of positive charge taken the direction of মানে electronic taken the direction of electronic current. Electronic current. Okay, so electronic current, however, negative charge moving one direction is equivalent to and positive charge moving its opposite direction. It's always remember that one point note that negative charge denoted direction is one direction and positive positive charge direction one direction, where negative charge denoted its opposite direction. So it is clear that negative positive charge directions, as the negative charge direction is also definitely it will be the different. So how many things you learned here basically. And electronic charge, now come to the point, an important point is that is electronic current is a scalar quantity, and why a scalar quantity? There are so many exams are coming that is a current is a scalar quantity. Electronic current scalar quantity is a scalar quantity. What you will give the answer? So basically when electric current has both a magnitude and direction, you know, very much familiar about this, and yet a scalar quantity, yet it is a scalar quantity. This is because the laws of ordinary algebra are used in the electronic current, and the lower the laws of factor addition are not applicable to the addition of the electric current. মানে vector algebras are not applicable. So that's the main reason. Let's say I'll give an example. So I'll first write down the definition. The electric current has both magnitude. Let's say the electronic current has both magnitude and direction. Okay, we know that, but still it is scalar quantity. But still it is scalar quantity. Why? Because matlab, the laws of ordinary algebra are used to an electronic current, and the laws of vectors of additions are not applicable to the addition of the electric current. So I will write here the thing that the laws of ordinary algebra, the laws of ordinary algebra the laws of ordinary algebra are used to add, okay, electric current, and the laws of vector additions are not applicable. Add electric current and the laws of vector addition are not applicable. The laws of vector addition are not applicable. Okay, so that's the main reason. Okay, I hope you understand that why it is not happening this type of things. So if I want to give an example, so how I'll give you an example. Let's say this direction is this is 1 ampere. This is, let's take this is 3 ampere. Okay, so 3 ampere, and it is also 4 ampere, and this take is coming out 7 ampere. So in this algebra, there's a 2 ampere and 3 ampere following two mutually perpendicular wires, and meets to the junction. इस junction पे ये लोग meet कर रहा है, ठीक, let's say give A, B and C, this type of, so it's a माने meet कर रहा है कहाँ पे, O junction. Then the current where OC is 7, the scalar addition, and 3A and 4A, but and not 5A. Not 5A. So that's the main, not 5A. It is not is not মানে required to vector addition. So that's the main reason. I hope you understand. It is clear that I am again I am going to clear that when the electric current has both, we know that very much familiar that electric current has মানে magnitude as well as direction. So it's cleared. Okay, and after that when you will learn that the laws of ordinary algebra are used to add an electric current. Ordinary algebra is used to add an electric current, but the laws of the vector additions are not applicable to the through the addition of electric current. So that's the main reason. It is called the scalar quantity. Now move on with an important topic like formula. So formula sheet. So for formula sheet, how what will be? So we have learned that first electric charge. Okay, charge, we have learned that the charge, time as well as electric current. So first introduced time is equal to T, charge introduced as a Q. Okay, and electric current electric current introduced as a I. Okay, so when মানে it is denoted, okay, it is denoted and introduced that number one point, electric current is equal to electric current is equal to charge by time, charge divided by time is called what? It is called electric current. Okay, which is called that the q by t, where charge q is the charge and t denoted by time. So rate of change of charge per unit time, unit area is called an electric current. Okay, and second जैसे कि q is equal to ne means number of electrons. Okay, so number of electrons is basically, it is called called an electrons, and for when it will convert it into I, so I will be what? I will be ne divided by t. Okay, so number of electrons divided by time. Number 3 case, মানে an electron revolving in a circular radius with a radius r and speed হচ্ছে v, the period of the revolutions of electron is what it will be. जैसे कि an electron revolving in a circle, electron revolving in a circle, okay, electron revolving in a circle of radius, or remember that electron revolving in a circle of radius r with speed what? Speed v. So the period of revolutions of the is, so the period of revolution, so period of revolution mm, that what it will be? It will be basically t is equal to 2 pi r divided by v. T is equal to 2 pi r divided by v. T is equal to 2 pi r divided by v. So this will be the মানে revolutions of a current. So frequency revolution, what it will be. So now come to the frequency revolution. Frequency revolution is equal to basically v is equal to 1 by t. So what it will be? V by 2 pi r. Okay, so v by 2 pi r is equal to current মানে frequency revolution, and current at any point of the orbit is মানে I'm already defined that current at any point defined current at any point defined I. Okay, so I will be what will be the I? So basically I is equal to basically charge following in one revolution divided into number of revolution per second. So it will be I is equal to ev is equal to e into v by 2 pi r. Okay, I think it is clear. And the unit, what types of unit are taken? It's a unit basically charge coulomb, and time second, and current ampere. So charge basically taken is a coulomb. It is denoted by q. Okay, time denoted as a second, which is denoted as time, charge time, as well as current. So current denoted as ampere. Okay, ampere, amp. So these the things, unit charge and constant use here always find at a constant. How you মানে constant you will get electrons মানে charge electron will be non-electronic charge, what will be 1.6 into 10 to the power minus 19 coulomb. This will be the constant here. I hope this concept is very much clear. Okay, so now coming to the form of problem solve part. Problem solving part, what it will be? Problem solving part. So for problem solving part, it will be definitely, let's say, taking an question, a question. Okay, that question is how many electron pass through a lamp in a minute if the current is 200 milliampere. Let's say, write that how many electron through a lamp, okay, lamp in 1 minute, in 1 minute. Okay, if the current is if the current is 300 मिली एम्पियर, मतलब 300 मिली एम्पियर अगर होगा तो इसका कितने तरीके, माने कितना इसके इससे कितना इसे टाइम निकल के जाएगा, माने कितना इसे आउटपुट निकल के आएगा. ठीक है, so the output will be what it will be. So basically here given that the I is equal to what? I is equal to 300 milliampere. What is milliampere? It's given I. So milliampere to convert it ampere, so 300 into 10 to the power minus 3 ampere. I'm going to given another kind of things that domestic lines, that 1 milliampere is equal to 10 to the power 6. 1 milliampere is 10 to the power 6. Okay, 1 milliampere is equal to 10 to the power minus 3 ampere. 3 ampere, or given that the 1 microampere is equal to basically 10 to the power minus 6 ampere. It is clear that? Okay, I hope it is clear. So now on the basis of this, here given that time t is equal to basically 1 minute. It's also given 1 minute is equal to 60 second. Okay, and E is also what? E is also 1.6 into 10 to the power minus 19 coulomb. And so I is equal to Q by T. So definitely the point of Q's and number of, so Q is equal to 300 into 10 to the power minus 3 into 60 second. Okay, and divided by, when it will coming out N, so N will be what? N will be IT divided by E. So number of electron. Okay, so that's the thing which I am writing, and divided by 1.6 into 10 to the power minus 19 coulomb. So when you will calculate, the result will be come out something like this: 1.12 into 10 to the power minus 10 to the power 20, 10 to the power 20. So something like this type of things are numbers will come out. It is clear? Let's second problem. Taking second problem, let's say they are given that 1 billion electron pass from 1 billion electron pass from 1 billion electron pass from a point just let's say P. Okay, towards another point Q, towards another point Q, in 10 to the power minus 3 second. So what is the current in ampere? The question is, what is the current in ampere? What is the current in ampere? First question. And second question is, what is its direction? What is it will be in direction? So what will be the answer? So what will be the answer? So basically here is the given, मतलब इस यहाँ पे क्या दिया है, यहाँ पे पूछा गया है कि इसका जो करंट है उस करंट कितना निकलेगा. तो मैंने पहले we will discuss that I is equal to number of electron divided by times. You know that. So here given that number of electrons, how many number of electrons. So the number of electrons, there is nothing given nothing but 1 billion. So 1 billion 1 billion is equal basically 10 to the power 9 minus 9. Okay, so 10 to the power 9 into 1.6 into 10 to the power minus 19 coulomb. It is basically the constant. Okay, and 10 to the power minus 3, it is also second, which is given here, you can see. So after the calculation, what will be the come out? 1.6 into 10 to the power minus 7 ampere. And which is a positive direction, positive direction. Okay, so that's the question was, and that's the thing was. now इसे थोड़ी बहुत टफ सवाल करने वाले हैं, ठीक है। जैसे कि लेट्स से एन इलेक्ट्रॉन मूव्स इन ए सर्कुलर ऑर्बिट, इलेक्ट्रॉन मूव्स इन ए सर्कुलर ऑर्बिट, रेडियस 10 सेंटीमीटर. Third question, an electron revolve and in a circular orbit, electron revolve in a circular orbit of radius what? Electron revolve in a circular orbit of radius 10. Okay, 10 centimeter with a constant speed, with a constant speed of 4.0 into 10 to the power 6 meter per second inverse. Okay, determine the current, electric current at a point on the orbit. So the question is determined the electric current a point on the orbit, how you will determine that? It's given, it said that an electron move in a circular orbit with radius 10 centimeter. The constant velocity is 4.1 centimeter. So the determined that the electric current at the point, इसके इससे इसके इससे जो चीज़ सबसे डिटरमाइन करना होगा वो क्या है कि सबसे पहले मुझे इसे टाइम इंटरवल को निकालना पड़ेगा. So basically it will given that we know that t, what we will get, t is equal to basically 2 pi r divided by v. We have already written that. So here 2 pi into r, radius of what? Radius is basically 1.0. Here given that the radius is also given here, you can see it. This is the radius. So the radius is basically 10 centimeter. So 10 centimeter converted into meter, so 0.10. Okay, and divided by times is given that 4 into 10 to the power 6 second, 4 into 10 to the power 6 second. So what will be the come out? So and we know that very much velocity is divided by 1 by t, and nu is equal to 1 by t, this is the frequency. So 1 by t is basically 4 into, let's say 4 into 10 to the power 6 divided by 2 pi into 0.10 second inverse. Okay, so I is equal to what? Nu e. So for nu, here you can get I get 4 into 10 to the power 6 into 1.6 into 10 to the power minus 19 coulomb. Okay, divided by y 2 pi into 0.10. So 0.10, what will be the answer come out? So the answer will be 1.02 into 10 to the power minus 12 ampere. So this will be the ultimate answer of this. Okay, so again I am saying one thing, that when the question will ask you that the electron moves in a circular orbit to the radius, okay, to the radius with the constant speed, okay. So an electron move in a circular orbit of the radius r, the radius is given also, okay, 10 centimeter, and the constant speed also given, that 4 into 10 to the power minus 10 to the power 6 millisecond. So determine that the electric current at the point of the orbit is also given that. So the answer will be 0.02 into 10 to the power minus 12 ampere. So this will be the ultimate answer. Now the next topic, what will be the maintenance of the steady current of an circuit. Steady current, it means how you will maintain an steady current. So for a steady current, the given the follow of the current movement in a current in an logicius of the follow of water in a pipe, just like just like that. This is look carefully. This is a water point where the waters are stored, okay. And this is connected also a pipe, okay, here. And this is also connected as a pressure P. So uh, wait a minute. Wait a minute. So this type of things here given that the pump, okay. So when the water, this is the height, this is height, given as height. So water pump, if upper places of the water, stored waters are falling down in the lower tank, and lower tanks what lower tanks doing, lower tanks consumes that level of waters and pumping to the upper level, and for that reason it will be the steady, and that state is called steady state. So steady state is basically this type of things. This type of, I hope it is clear. It is very much basic. No need to explain much more. But in circuitically, what it will be? Circuitically, it will be that said. This is a resistance. Okay, this is so. Oh, sorry. Let's say this is resistance. Okay, and here given that it is a source. Okay, here you can see that this is source, as well as wait. So this is the thing, and also this type of things, okay. Now listen, that the source of EMF, this is the source of EMF. What type of things is source of EMF? Money, charge pump. This is a charge pump, okay. This is also positive and this is negative, and this is the resistance, okay. So in the resistance, the main steady current through the conductor, some external voice must do work at a steady rate, and taking that the positive charge from the lower potential to higher potential. Such device is source is the electromotive force. So here you will get the source of electromotive force. So a source of EMF, yani electromotive force, transfers to the positive charges from the lower potential to the higher potential in the opposite directions of the electronic field. So clearly the charge follow electrics, and charge follow law, the current is analogous to the weather water follow of the circuit. Now electromotive force, yani EMF. What is the EMF? So basically EMF, you can find EMF in the batteries, okay. We are very much familiar electromotive force. So the next topic is electromotive force. electro electromotive electromotive force yani EMF, electromotive force, which is said that EMF. What is EMF? So EMF is basically it is a source may be defined as the work done by the source of taking per unit charge from lower to higher potential. That's the main definition. So main definition I am writing here. So definition, what it will be the definition? So definition will be the electromotive electromotive force, the electromotive force of one source electromotive force of one source may be defined as the work done as the work done as the work done by the source in taking by the source in taking a unit positive charge from lower to higher potential, from lower to higher potential understand that. So this is called electromotive force. So electromotive force is nothing but it is used as electromotive force of one source may be defined as the work done by the source in taking a unit positive charge from the lower to higher potential. It is a unit positive charge from lower to higher. So if somebody asks you that what is the EMF, then definitely I think you will be able to explain that the electromotive force of one source may be defined as the work done by the source in the taking at a unit positive charge from the lower to higher potential. It is clear that I think. Oh, okay, I'm going to explain. So how you will explain EMF? Explain of EMF. How you will explain EMF? So basically, when you will, we are very much about familiar about what batteries. You are very much familiar about batteries. So batteries is, there is the two sides. There one side is called anode, another side is called cathode. So for charge difference, let's say this is positive and this is negative. This and giving this name anode, and this is also cathode or B, giving name B. So number of electrons or so number of electrons will come out. In this figure you can see that due to certain chemical relation, a force is exerted on the positive of the and electrolyte. Okay, so the force is positive charge towards the A terminal and the negative charge towards the B terminal. Suppose, let's say suppose they are given that the positive charge A positive charge Q or in n directions as the charge build up two terminal A and B. Okay, and A potential difference to the setup between them. The electronic field E is the setup of electrode. Okay, from A to B, and this field is exerted from the Fe to QE on the charge. Okay, so the opposite directions of number of E is steady state. It is clear that, and the charge of stop accumulating is basically, what will be the charge of stop? So the charge of stop accumulating is number of electron is equal to number of hole is basically is equal to number of electron. So the work done, what will be the work done? So what the work done work done work done what will be the work done? So the work done is basically F is equal to uni F and D, where D is the distance between A terminal and B terminal. Let's say even that, where D is basically the distance between a terminal and B terminal A terminal and B terminal. So ultimate thing is that that the source of the terminal will be A terminal and B terminal. So work done per unit charge, what will be? So W by Q. So work done per unit charge, what will be? Now work done per unit charge. So work done per unit charge, what it will be? So work done per unit charge will be that the summation is equal to W by D. Okay, where F and D divided by Q. মানে the quantity epsilon is equal to W by Q is called that the electromagnetic force or the EMF battery of any other source. Okay, মানে if two they are say given that if two terminals মানে battery are not connected, okay, externally, then মানে if both are not connected, then number of holes and number of electrons is equal to Q is equal to any. Okay, মানে where B, let's say মানে let's say given an example, মানে important point that two terminals are not connected, that two terminal are not connected, then what it will be? If two terminals are not connected, then definitely number of basically f of n is equal to f of e. So number of hole is equal to number of electron is equal to basically Q is equal to E. Okay, it is clear that, and at the same time f of n into D is equal to f of E into D. This is also work done. Okay, so distance between anode A point A to anode cathode or point A to point B, and it is also represented as QV. QV, clear that? So when B is equal to ED, the potential difference between the two terminal, then what will be the potential difference? Potential difference between two terminal. The potential difference between two terminal, what it will be? The potential difference between two terminal will be what? No, potential difference between two terminal will be epsilon is equal to f of n into D divided by Q. So f of E is equal to QV divided by Q. So it will be V. So it is clear. Okay, so what it will be, the diagram, let's say this is a source, okay, and this is resistance. So this is positive and this is negative. Positive negative, when the two electrodes exchange charges with the electrodes, consequently positive cathodes P develop positive potential, where V is the greater than 0 with respect to its and electrode of A, and the negative electrode N develops to the negative potential. It's the thing. Okay, so I hope you understand. Work done divided by, what is the W by Q? W by Q is basically EMF. Just say for concept wise, EMF is basically EMF, electromagnetic force, is equal to work done divided by charge. Okay, work done divided by charge. This is EMF. This is EMF big concept which you will learn. So EMF epsilon is equal to W by Q, always written, sorry, small w Q, it's always written, and SI unit of EMF is volt. Unit SI unit of EMF is what? Volt. So these are the things. It is cleared like water. I think and now it is very much clear, like crystal clear for you. Okay, wait a minute, I want to drink some little more water. So volt is clear. Okay, then what is the difference between electromagnetic force and potential difference? What is the difference between, what is the difference between EMF and potential difference? EMF and potential difference. Potential difference. What you will said. So for electromotive force, what we learn in the electromotive force is basically, it is the work done by a source in taking a unit charge once around the complete circuit. Where the potential difference, it is the amount of work done in taking a unit charge from one point to another of the circuit. So now I will write here that number one, and that it is a work done EMF, this side EMF and this side PD, any potential difference. Okay, so EMF, EMF, it is work done. It is work done by a source, by a in taking a unit charge once around the complete circuit. Unit charge once round the complete circuit once round the complete circuit. Okay, and same for potential difference, it is the amount of work done. It is the amount of work done. It is the amount of work done in taking a unit charge, in taking a unit charge. Okay, taking a unit charge from one point to another, from one point of the circuit to another, from one point to another circuit, from one point to another circuit. Okay, to another circuit to another. Okay, so that's the things. Okay, it is the equal to the maximum potential difference between the two terminal at the source when it is open circuit. When the electromagnetic force is equal to the maximum potential difference between the two terminal of the source when it is in an open circuit. Okay, at the same time potential difference may exist between 2 point if 2 points of a closed circuit. It is not sure that it will be happened or not. So the second point, is it is equal to the maximum potential difference potential difference maximum potential difference between the two terminal between the two terminal of a source of a source when it is in an open circuit, when it is in an open circuit. Okay, when it is in an open circuit, remember that. At the same time, potential difference, what it will be, Potential difference may exist between any potential difference between uh, um, mm, any 2 point of closed circuit, between any 2 point of closed circuit. Remember that any 2 point of closed circuit. At the same time, number three lets it exist even when the circuit is not closed. মানে is also exist when the electric circuit is not closed. It exists, potential difference exists when the circuit is closed. It exist when the circuit is not closed. Circuit is not closed, or it exists it exists when the circuit is even closed. माने पोटेंशियल डिफरेंस तब भी एग्जिस्ट करेगा अगर पोटेंशियल डिफरेंस नहीं भी है, ठीक है। और जो उसके वाला जो माने एक टॉपिक है, जो मेन मुद्दा है कि व्हेन ईएमएफ इज अप्लाइड इन ए सर्किट द पोटेंशियल डिफरेंस इज कॉज्ड। माने जब भी तुम किसी सर्विस के माने किसी भी सर्किट के अंदर पोटेंशियल डिफरेंस को अप्लाई कर दे गई इलेक्ट्रोमैग्नेटिक फोर्स, then the potential difference is caused. Potential difference automatically it will happen, but the potential difference at the same time মানে potential difference will be affected, not be caused. Okay, so and at the same time in other field that it is equal to the sum of potential difference across the component of the circuit, including the potential difference is required to send the current through the every component its own potential difference across the if there is the use side of potential difference, just say it is larger than the potential difference across any circuit element. At the same time it is always less than the emf. And 8 point is it is independent of the external resistance in the circuit, and it is always less than the emf. মানে potential difference is always less than the emf. So the last point, let's say that the fourth point, it is independent of the external resistance. It is independent of the external it is independent of the external resistance in the circuit. Okay, circuit के अंदर क्या होगा, it is also independent. Okay, at the same time fourth point, it is always less than the emf. It is always less than the emf यानी electromagnetic force. Okay, clear? I think it is clear. Okay, now the fifth point is what it will be. The fifth point is it is larger than the potential. It is larger than the potential difference यानी PD. Okay, across any circuit. Across any circuit. Okay, at the same fifth point is that it is always less than the emf. It is always less than the emf. It is always less than the emf. It is clear? Okay, Clear. So now now the difference between potential difference, what it will be the potential difference as well as the EMF. Mane, it is work done by a source and taking that the unit charge are once round to the once around the complete circuit. At the same time, potential difference also, it is the amount of the work done in taking a unit charge from one point to another point of the circuit. At the second point, it is the equal to the maximum potential difference between the two terminal of the source, and when it is an open circuit, okay, and the potential difference between any 2 point is closed circuit. And third point is it exists when the current is not closed. Potent EMF is also exist when the current circuit is not closed, but the potential difference exist अगर 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 EMF एग्जिस्ट नहीं है, इसका मतलब यह है कि वहाँ पे अंदर माने सर्किट क्लोज नहीं है, ठीक है। लेकिन बट एट द सेम टाइम इफ द सर्किट इज it is exist when the circuit is also even closed, सर्किट तब भी क्लोज रहेगा, क्लोज रहने के टाइम भी ये क्या होगा कि ये एग्जिस्ट करता रहेगा, ठीक है। So that's the things, and it is the larger than the potential difference across any point of the circuit, and it is money electromagnetic force. At the same time, it is always less than the EMF. Clear. Now the point is Ohm's law. Ohm's law. Ohm's law, it is very much important, okay. Ohm's law is very much important. So Ohm's law, what it will be? So on the basis of his experiment, Ohm's experimental observation, he was a German physicist, he is a German physicist called Salman Ohm derived the relationship between the electronic current and the potential difference. इलेक्ट्रिक करंट इन्होंने क्या किया है, इलेक्ट्रॉनिक करंट और पोटेंशियल डिफरेंस के अंदर क्या लाया है, एक रिलेशनशिप लेके आया, रिलेशनशिप, ओके। So in 1928, which years? 1928. So 1928, Ohms discovered one thing, that he stabilized a law. The relationship is known as Ohm's law, and can be stated as इसको किस तरीके का स्टेट किया जाता है, ठीक है। इसका statement said that that the current flowing through a conductor is directly proportional to the potential difference. यानी current flowing through a conductor, current flowing through a conductor is directly proportional to the potential difference, proportional to the potential to the directly proportional to the potential difference applied across its condition, applied across its ends, applied across its ends, okay, across its ends applied the temperature, provided the temperature and other physical condition remain unchanged, provided the temperature other Okay, so provide the temperature and other physical conditions and other physical other physical condition remain unchanged, remain okay. It is clear that remain unchanged, okay. Remain unchanged. So potential difference basically मुद्दा कथा में बात में ये होती है कि the potential difference directly proportional to the current, directly proportional to current, okay. So V proportional to potential